Have you ever wanted to learn to code but kind of got scared off thinking it was going to be all, complicated math? Well, what if I told you it's actually way more like learning a new language, one with its own alphabet, its own words, and its own grammar? So today, we're going to crack the code on the basic grammar of Python, and you'll see just how easy it can be to start talking to your computer.
So let's start with the big question. What are programming languages really made of? And that is a fantastic question. Because just like English is built from letters and words, every single programming language is built from just a few core fundamental ideas. Let's start at the very beginning. You see, at the end of the day, programming is just a conversation. But instead of talking to another person, you're giving a computer a set of super clear instructions. So forget about the complex math for a second. Just think of it as telling a very literal-minded friend exactly what you want them to do, step by step. And that is where Python really shines. It's why so many people start their coding journey here. It was designed from the ground up to be readable, to look almost like plain English. It just makes that first conversation with a computer feel so much more natural. All right, so just like any language, whether it's Spanish or Python, it all starts with an alphabet. We have to begin with the most basic building blocks, the individual characters we're allowed to use to write our instructions.
And here it is. This is Python's alphabet. You'll see a lot of familiar stuff, letters, numbers, and all those special symbols. But here's the kicker. See that last one? White spaces? Those invisible characters, like a space or a tab, aren't just for making things look pretty. In Python, white space is actually a crucial part of the grammar itself. Wild, right?
Okay, so once we have our alphabet, we can start forming words. In the world of programming, we call these words tokens. A token is simply the smallest possible unit that actually has some meaning. This is a really key idea. Before a computer can understand your whole sentence, it first has to break it down into these individual words, these tokens. And this chart here breaks it down nicely. All of Python's words, its tokens, fit into 5 main categories. You could almost think of them like parts of speech in English. We've got keywords, which are special reserved words, identifiers, which are names we create, and operators, which are symbols that do stuff. For now, let's focus on those last 2, because they're the ones you'll use the most. Now we get to the fun part, building our sentences. Just like in English class, we combine nouns, words that name things, with verbs, words that do things. This is how we form complete thoughts, or what we call statements in the coding world. This slide makes that analogy super clear. On the left, we've got identifiers. These are our nouns. They're just labels we make up to name things, like a variable we might call user_h. And on the right, we have operators. These are our verbs. They're the symbols that actually perform actions, like adding 2 numbers together or checking if they're equal. And here are some of the most common verbs you'll use all the time in Python. You've got your arithmetic operators for doing math, your relational operators to compare things, and your logical operators to combine different conditions. These guys are the real workhorses of any program. Okay, so we've got our nouns and our verbs, but there's one more crucial piece to this puzzle. The computer needs to know what kind of information it's dealing with. Is it a number? Is it text? This whole concept is called a data type, and it's what gives our data shape and meaning. And lucky for us, Python gives us this awesome little built-in tool to play detective. It's a function called type. You can wrap pretty much any value inside of it, and Python will tell you exactly what kind of data it thinks it is. Let's check it out. First up, we've got the integer, or int for short. This is your classic whole number. No fractions, no decimals. Just simple, clean numbers like 1, 2, 3, or maybe -50, or even 0. So if we ask Python, hey, what type is the number 123? It comes right back and tells us that belongs to the class int. It's an integer. Simple as that. But what about numbers that aren't whole? Well, for those, Python uses something called a float. The rule is really easy. If it has a decimal point, it's a float. And just like before, if we run our little test on 12.34, Python correctly identifies it as a float. This is how the computer tells the difference between whole numbers and numbers with, fractional parts. All right, now for text. This is a big one. In Python, any chunk of characters inside of quotation marks, single or double, doesn't matter, is called a string. This is how we handle words, sentences, basically any text data you can imagine. And no surprise here, if we ask Python for the type of hello world, it confirms that it's a string, which is just short for string. Those quotes are the dead giveaway.
And finally, we have maybe the simplest, but also one of the most powerful data types of all, the Boolean. A Boolean can only ever be one of two things, true or false. That's it. Think of it like a light switch. It's either on or off, and that's incredibly useful for making decisions in our code. You'll see these Booleans pop up all the time as the result of a comparison. For example, if we ask the computer, hey, is 5 equal to 5? Well, that's a question with a very clear answer, and that answer is the Boolean value true. All right, we've got our alphabet, we've got our words, both nouns and verbs, we know about our different data types, we've basically learned the grammar. Now, it's time to put it all together and have a real, actual conversation with the computer. You know, a good conversation isn't a monologue, right? It's a two-way street. To make our code interactive, we need two essential tools. First, the input function, which basically pauses everything and waits for the user to type something. And second, the print function, which is how our program talks back to the user.
And this is where it all clicks into place. Let's look at this tiny program to calculate a rectangle's area. First, we use our input function to ask the user for the length. See how we wrap it in int? That's because input always gives us a string, and we need to turn it into an integer to do math. We do the same thing for the breadth. Then we use our identifiers, our nouns like length and area, to store the values. We use the little star, our multiplication operator, that's our verb, to do the calculation. And finally, we use print to show the result on the screen. See? Alphabet, nouns, verbs, data types, all working together in one perfect little conversation.
So there you have it, the fundamental grammar of Python. It's not some crazy, complex magic. It's just a language with rules you now totally get. The only question left is, now that you know how to speak the language, what are you going to create?